One line of algebra hides one of the hardest problems in our bank. Let me solve it with you, thinking out loud. Here it is. A non-zero polynomial satisfies x times p of x minus 1 equals x minus 3 times p of x for every real x. We know one value. P of 4 is 24. Find p of 5. Read that last part again. For every real x. When a problem says every x, that is usually where the leverage is. What do we have? Given, an identity that holds everywhere, plus one concrete value. Wanted, the next value up. Should I draw a figure? The only picture here would be the graph of p, and p is exactly what I don't have. A sketch cannot carry this constraint. A ledger can. And since the identity holds at every x, I get to pick. Which x? I want an x that makes one side trivial. X equals 0 kills the left. 0 equals minus 3 times p of 0. So p of 0 is 0. A root, and it costs nothing. X equals 1. The left side is p of 0, which is 0. So p of 1 is 0 too. X equals 2 pushes again. P of 2 is 0. A cascade. So try x equals 3. The right side is 0 times p of 3. 0 no matter what p of 3 is. Nothing. It stops there, and 3 roots is already a lot to know. A polynomial with roots at 0, 1, and 2 is divisible by x minus 1, by x minus 2. So p is x times x minus 1 times x minus 2 times something. And I give the something a name, q of x. The name is doing work. It stores what I know, so the identity can tell me what is left. I don't know yet what this buys me, but the identity is the only tool I have, so put p back in. The left unfolds into x minus 1, x minus 2, x minus 3, times q of x minus 1. The right, the same 4 factors, times q of x. Cancel them. Allowed everywhere except 4 points, and 2 polynomials that agree everywhere else are the same polynomial. What survives? Q of x minus 1 equals q of x. A polynomial unchanged when x slides by 1. Then q is the same at every integer, and a non-constant polynomial can take one value only finitely often. So q is a constant. The rest is bookkeeping. P is a constant c times those 3 factors. Feed it the given value, and the constant has no choice. C is 1. Then p of 5 falls out, 60. And I don't trust an answer I haven't tested, so put x equals 5 into the original identity. Both sides land on the same number. It holds. Looking back, 2 decisions did the work. Plugging in the x that makes a side vanish. That is how the roots appeared. And naming the quotient. That is what turned the identity into a statement about the one thing I didn't know. To try this kind of solving yourself, there are harder problems than this one waiting on Mathalon.